So for this following problem, we have given in here two chemical equations. Half moles of nitrogen reacting with half a mole of oxygen, reacting to form 1 mole of nitrogen monoxide. Now the K sub C is known for this one. Let's call it as K sub C1. And that is known to be equal to 4.8 times 10 to the negative 10 at some unspecified temperature. Also given to us is the second equation that we have. So there are 2 moles of nitrogen dioxide decomposing to form 2 moles of nitrogen monoxide and oxygen. At this same temperature, its K sub C is also known. We call it as K sub C2. And it is equal to 1.1 times 10 to the negative 5. Now with all of this particular data known to us, we are now asked to compute what would then be K sub C for the following given reaction, which is coincidentally going to be the sum of the two known equations given to us. So to solve for this one, let's try to see what algebraic manipulations we have to do in order to arrive at the equation being asked of us to find the K sub C. So looking at the unknown equation, we have our nitrogen dioxide on the left side of the equation, arrow. So we copy the second equation that we were given. So that's 2 nitrogen dioxide decomposing to form nitrogen monoxide and oxygen. The K sub C of which is already known to us. That's equal to 1.1 times 10 to the negative 5. Now notice that if we compare this equation right here with the equation whose K sub C we are looking for, we can see that on the right side of the arrow, there should be no nitrogen monoxide present in there. Now to do this, we should be able to cancel out completely the 2 moles of nitrogen monoxide that we have. And to do that, we use our first given equation. So we simply flip over the first given equation to give us nitrogen monoxide gas. And to completely cancel the nitrogen monoxide gas that we have in here, we multiply the first equation given by 2. And that gives us the following. Now by flipping over the chemical equation for reaction number 1 and then multiplying it all by 2, we are now able to also change the value of its K sub C. So the new value of k sub c for reaction number 1 is then equal to 1 over 4.8 times 10 to the negative 10. Since we have reversed the given equation, and once that is done, we have to also raise this one to the power of 2, since we've multiplied the given equation by 2. Now summing up the chemical equations that we have to check if we are able to arrive at the equation whose k sub c is unknown, we now get 2NO2 gas plus 2 nitrogen monoxide producing 2 nitrogen monoxide plus oxygen plus 1 mole of nitrogen and yet another mole of oxygen gas. The nitrogen monoxide molecules are going to be cancelled out since they are present in both the left and the right side of the equation arrow. And so we are left with the overall chemical equation, which is 2 moles of nitrogen dioxide decomposing to form nitrogen plus 2 moles of oxygen. Now to get the k sub c overall for this particular equation, we have to just simply multiply the value of k sub c for this equation right here, as well as the new value of k sub c that we compute over here. So plugging that in, we have 1.1 times 10 to the negative 5 multiplied by k sub c 1 prime, which is actually going to be equal to 1 over 4.8 times 10 to the negative 10 squared. Plugging all of that into the calculator gives us the value of the k sub c for the overall equation, which is then equal to 4.8 times 10 to the power of 13.